In this nugget, we take a look at TCP/IP configuration, which allows you to not only configure it properly in the first place, but to avoid troubleshooting problems in the future, because improperly configured TCP/IP settings are responsible for a lot of networking problems. So it kind of builds in troubleshooting into the same nugget here. Now, TCP/IP properties are going to include things such as the default gateway, which is important when it comes to figuring out whether or not a system can route to other networks on your network, or whether it can route to the internet and so forth, or whether we want it to be able to communicate only on its own local broadcast domain. Then we take a look at DNS suffixes as well, which is the second part of a name. For example, if I'm dcnugget1.nuggetlab.com, well, the nuggetlab.com portion of that name would be the DNS suffix. And that's important because it'll configure, or rather be relevant to, how this system is registered in DNS and how it finds other hosts in DNS. And then we'll talk about how it registers itself in DNS using dynamic DNS, and there are several settings for that in the TCP/IP configuration. We can also disable NetBIOS if necessary. There are some security vulnerabilities, so you might want to know about that. And if you want to further secure your system, you can use TCP/IP filtering. Well, let me ask you a question before we get started here. Do you have a junk drawer? Might be in your office, might be in your kitchen, something like that. It's full of pencils and rubber bands and paper clips. In fact, I've got a junk drawer here in my office. It's got here's a pocket calculator. Let's see. Here's some smart cards. Here's a key ring full of keys that I have no idea what any of these go to. Aspirin, pretty much got to have those. That's a staple diet in the IT profession. Screwdrivers. Oh. Here's a pair of handcuffs. Hey, how'd those get in here? Oh, that's right. Ooh, these can go on pretty tight. Ow. Okay, now, let's see. There's also a key in here somewhere. Keys. Keys. Where are the keys? Alright, I'm just going to pause the recording for just a second, and I'll get right back with you. Okay, well then, I'm back, and thankfully I did find a key to the handcuffs. That wasn't embarrassing at all. Okay, now let's go ahead and talk about why I mentioned a junk drawer in the first place here. Well, TCP/IP configuration and troubleshooting is a lot like a junk drawer. There's not really a single purpose for all of this stuff that's in there. I mean, it's just a bunch of miscellaneous things in a junk drawer. And in TCP/IP configuration, it's just a series of radio buttons and checkboxes and all different kinds of things like that, as well as the various tools that you use for troubleshooting. There's several different command line tools, for example, that you'll use. And to understand all of this, first of all, let's go ahead and go to the Start menu, where we'll go to the Control panel, and then we'll go to your network properties, and we'll first of all look at properly configuring TCP/IP within Windows, and this, by the way, also applies to any current version of Windows, not just Windows Server 2003. And we'll take a look at the configuration there, because that's often where troubleshooting problems come up first. Now, in order to show you that, I'm actually going to connect to another machine, and for this nugget right here, and for pretty much a lot of what I do throughout the remainder of this course, I really use remote desktop. Now, I covered that in another series, but just as a quick summary here, remote desktop allows me to connect to another computer as if I were seated there locally, and it's pretty much the same as terminal services in most respects, if you've ever used that in the past. And that's what allows me to use a single machine to record and to teach on, as well as using multiple machines to show you network computers. Now, here I'm just going to click on the remote desktop client, which I've put in the quick launch area down here. So I'll click on that, and I'm going to connect to another server called DC Nugget 2, which actually is just a member server in the nuggetlab.com domain right now. Now I'll go ahead and log on as trainer, which is my administrator account, which is just a copy of the domain administrator account. Therefore, it's a member of enterprise admins, domain admins, and all of that kind of stuff. So I can pretty much do whatever I need to do using this account. Now once I get here, we'll get to the network card properties by going to Control Panel and then Network Connections. And I can right-click here and choose Open if I have multiple connections that I want to check at one time. Or I can just right-click on this local area connection and choose Properties. Either way you want to get there, both work. And then here, once I get into this, let's just discuss a little bit about what we see here so we can get some frame of reference and context. First of all, we have this named network card right here, and if you just hover over it, in fact, it also shows you the MAC address, which is just kind of handy to see. We'll talk more about MAC addresses a little bit later on, but that's a unique identifier for the actual hardware of this network card. And then if I want to go to the configuration of that hardware device, I click on Config here, and it takes me to the hardware properties of this device, and I can look at the drivers and update drivers and all that kind of stuff. In any case, when we go to the actual properties for that network card, and then I guess I canceled out of that, so I need to get back back into it here. Then we see, as far as the TCP/IP local area connections is concerned, we have this item right here, which is installed by default in all current versions of Windows, which configures TCP/IP for you. Now, for context, Client for Microsoft Networks allows me to access resources on some other server on a Microsoft network. For example, shared printers, file shares, that kind of thing. Various kinds of applications might need a file share, for example. Your data would need a file share on some other server, that kind of thing. Network load balancing simply allows me to use exactly what it sounds like, to balance the load between two or more servers so that one server is not slammed with a service of some kind or with an application of some kind, and it can instead be balanced among multiples. And this is often what will happen. For example, you use this a lot in things like web farms, where you don't want one web server getting hit with everything. You want to balance it out. Finally, printer sharing for Microsoft Networks is what I will configure if I am the server, or I'm at the server, that I want to share off a file share or share an application or share some kind of a printer, something like this. Then we can also show the icon in the notification area when connected, and I'll just click that for now, and you'll see it in the bottom down here after I click OK a little bit later on, just for your frame of reference. But it just looks like two little tiny computers there, and they light up when they send or receive traffic, and it's just a visual clue that the network card is connected and transferring traffic. And then finally, and what we're really here for is the Internet Protocol TCP/IP properties, which if I double-click on that or click on it and then click on Properties, it brings up the properties for TCP/IP, which we see here. Now then also, on almost any server you'll see, most administrators will use a static IP address. That means that they're going to manually type in the IP address, subnet mask, and all the other configuration for the TCP/IP configuration settings. You can also obtain an IP address automatically, as well as a DNS server address automatically. And all that means is that it's going to get an IP address from a DHCP server, which is a dynamic host configuration protocol server, and it distributes an IP address out of a pool of addresses, and it includes all of the configuration, the WINS server address, the DNS server's address, the default gateway, the subnet mask. All that stuff is included in the DHCP server's distribution of an IP address, and we'll talk more about that, a lot more about that later on, and we'll also talk a lot more about DNS servers, which will resolve host names to IP addresses for us. So anyway, like I said, almost always on servers, as well as things such as print servers or printers with static IP addresses, you'll always enter the IP address statically here. That way, I can always look at an IP address that might be maybe throwing out broadcasts on the network, and if I see that the IP address is 10.10.10.22, then as an administrator, I can say to myself, oh man, that looks like our print server. Wonder why it's broadcasting. Then I know exactly which server to go to start troubleshooting. And so overall, it's just a good idea for consistency. Now, on this server, for example, I'm going to use 10.10.10.22, like the IP address I just mentioned a moment ago, and a subnet mask of 255, if I can type right, 255.255.0. Now, while I'm here entering in the subnet mask, just review with me over our last nugget and identify with me what class network ID I'm working with here, a 10 dot network address. Well, that's a private IP address, and it's in the Class A range. And even though it's a Class A range, notice that I'm using a Class C subnet mask, which is fine. We talked about that also in the last nugget. Now, I want to point out another thing about this, by the way, before we move on, though, and that is, if we go to Notepad and we look at this in binary again, so let me just kind of make it so we can see everything at once. We got a subnet mask, or IP address, of 10.10.10.22, and a subnet mask of 255.255.255.0. Well, this, of course, is a network ID of 10.10.10.0 if I don't want to specify a specific IP address. This .0 just identifies that I've got this range of addresses. Now, another way to identify that I'm using a Class C subnet mask here is to do a /24. Well, where does the 24 come from? 8 bits turned on here, plus 8 bits turned on here, plus 8 bits turned on here. Well, that's 24. So we just enter in 24 there. That's kind of a shorthand way, and you'll often see that in Cisco networking, where they'll use that kind of a notation instead of the decimal notation for a subnet mask that you see down here. It just identifies the number of masked bits. So if I had a 29 here, for example, then that would mean that I've gone beyond my Class C and gone into a custom subnet of 248 is what that would be. So anyway, I just bring that up so that if you see something like this right here, then you know that, oh, they're talking about the 10.10.10. Network ID with a 29 masked bits subnet mask. Therefore, that would be this 255.255.248. Now let's go ahead and also take a look at the default gateway. And for that, let's go ahead and look at an illustration that shows you proper configuration of a default gateway. Now in this diagram, I address the default gateway setting that we just looked at in the TCP/IP properties. Here, for example, on this server over here, where I've got my 10.10.10.22 address with a Class C subnet mask designated by the /24, I want to be able to communicate with other networks. So if I want to be able to do that, then I'll have to configure the default gateway, which will be the router interface on this same network over here, and that would be a 10.10.10.1 configuration on my TCP/IP configuration properties for the default gateway setting. If I want to communicate with this server over here, then I would not enter in its configured default gateway IP address on this network. This doesn't matter to me at all. I don't really care about that if I'm on this network configuring this server. All I have to be concerned about is this IP address for this interface on my default gateway. Now likewise, if this was a server that for some reason we had extra security we wanted to configure, we'd probably see other things here, a DMZ, some other security measures, some firewall settings that we'd have to configure and all of that. However, if for some reason I wanted to take an additional measure and prevent this computer from ever being able to talk on the internet, to be able to reach other hosts on the internet here, or to prevent anybody else on the internet from being able to access this server and having it respond back to them on the internet, then what I would do is I would just completely blank its default gateway. That way, it would only be able to communicate with other hosts on its own subnet. Of course, as you would guess, that would also mean that it would be prevented from communicating with any other server, even other servers on other subnets within our own local networks here. So then when we return to our default gateway here, if I want to enter in the proper address and I did want to communicate with other networks and on the internet, that'd be 10.10.10.1, which is the interface on the router for the default gateway on this network. Now as for DNS server settings, if I'm again configuring this server over here, and maybe my DNS server is over here, then I'll need to be able to configure this IP address, or whatever my DNS server's IP address is, in the configuration properties of the server. Otherwise, the only way it will be able to resolve names without a WINS server as well, which is also an older kind of a name resolution method, would be to use broadcasting. And we generally want to cut down or eliminate broadcasts whenever possible. You'll never get rid of all of them, but you want to do it whenever you can. So here I'll enter in the IP address of my DNS server, and my actual DNS server is 10.10.10.20. And then what's this alternate DNS server? Well, that's what I'll enter in if this first DNS server is unavailable and can't be reached. Then I'll enter in maybe another one that's on the network that I can use as a backup, if you will. So maybe it's 10.10.10.4. Now, an important consideration to keep in mind here is that you do not have a misconception about the alternate DNS server. This is only going to be referred to, this client where I'm configuring this, is only going to access this .4 server if this one is unavailable. It's not like what my kids do, where if they go to their mother and they say, "Hey Mom, can we have cookies?" and she says no, then my kids come to me and say, "Hey Dad, can we have cookies?" Inevitably, I say yes, and so that causes a little bit of marital tension in my family. But anyway, that's not what this is about. It's not like this client goes to this server and it says, "Hey, do you know where, Microsoft.com is?" and this server says no. Then it doesn't say, "Well, if you don't know, then I'll go find it from somebody else." It doesn't go down here and then ask .4. No, instead what happens is, if this server says no, then this client, when I'm configuring these properties right now, will just say, "Okay, well, I guess I'll just have to accept that answer." And it does not access another DNS server running around like kids searching for cookies to get an answer. Because in reality, it did get an answer, just the answer was no up here. Now then, under Advanced Properties, here you see that I can enter in multiple IP addresses for the single network interface card, or NIC. And the purpose for doing that might be if I want to, for example, dedicate certain network traffic to one IP address and another kind of network traffic to another IP address. So, for example, maybe this is a web server, and I want all my www traffic as configured in Internet Information Server to go only to 10.10.10.22. And then I would add an additional IP address, maybe 10.10.10. If I can type here, 10.21. Maybe I want that to be used only for my general administration or for using terminal services connections to this server. I can also enter in multiple default gateways. We have an existing default gateway as configured in the dialog box behind that we see over here. That again appears here. And then I can also edit that if I want to, so that I can give it a specific metric. The metric is what calculates the speed of the interface, and I could just give that a metric, say, of 1 if I wanted to be very granular about how I configured that. Now, since I've only got one default gateway here anyway, it doesn't matter what I put there because that's what it's going to use regardless. But if I added another default gateway, 254 for example, then maybe that's my failover default gateway. And so that if the first router goes down, then maybe this one would still be available, and I might give that a metric of 2. That way, it's going to use this top one most of the time, except for if it fails, then it'll fail over to this other default gateway. Now, before I forgot, I went ahead and clicked OK through everything so I could just show you these little computers down here in the future tray area that show you the local area connection. And the computer in the foreground there that lights up, whenever it lights up, that means it's sending data. In the background, that means whenever it's receiving data. You can just double-click this if you want to also get to the properties for your network card. Now, let's return then to the TCP/IP properties into the advanced button and the DNS tab now, where we see our DNS servers available. You can change the order of these using up and down, and these buttons kind of explain themselves. Edit only means you'll just change the IP address. There's really no other configurable items there. And then down here we have some things relating to DNS suffixes, primary DNS suffixes, connection-specific DNS suffixes. This is kind of splitting hairs in terms of DNS, but it is important to know about. So let's go ahead and address how these relate. And to understand anything about them, we first have to understand what a primary DNS suffix is and what a connection-specific DNS suffix is. The primary DNS suffix is how this specific host, this local host here, DC Nugget 2, can be identified in DNS regardless of which network card it's being identified on. So let's go to take a look at our system properties by right-clicking my computer and choosing properties. And we get into this to go to the computer name tab and then the change button down here. We'll see that we have a more button here. We also see the full computer name, dcnugget2.nuggetlab.com. The reason why it appears as that full computer name is because on the more button we see that the primary DNS suffix of the computer is nuggetlab.com. So since the computer name's dcnugget2, it just appends that to the beginning of the primary DNS suffix. Now this is the default behavior to change the primary DNS suffix when domain membership changes. So if I were to join this computer to a different domain, cbtnuggets.com for example, then it would automatically change this to cbtnuggets.com, and it would then be known here as cbtnuggets.com as well. Now I could also identify this computer or associate it with a different zone if I want. So I could go back to more here, and I could change it to cbtnuggets.com or xyz.com, any other domain I want. In this case, maybe I want to go az.west.nuggetlab.com. So I have a few child domains, a couple of child domains there as well. Then you see that this computer name would then become dcnugget2.az.west.nuggetlab.com. And with dynamic DNS registration for our host records, which we'll talk about more as well, then it would automatically register under this name, provided I have a zone for that child zone. And we're not actually going to do that, so I'm just going to clear this for the time being. But you'll see how that comes into play a little bit later on. Okay, so let's get back into our DNS settings here. That was the primary DNS suffix, is what we configured on the system properties, and that will be something that will apply to any number of network cards that we have installed on this machine. However, for this specific network card and for these specific TCP/IP settings on this specific network card, I might enter in something like this, cbtnuggets.com, and with that, this network card's IP addresses would then be registered in the zone for cbtnuggets.com. So this computer would actually be identifiable through two separate zones. My original one, nuggetlab.com, and cbtnuggets.com, and provided I've got everything configured correctly, it could automatically register its own host record in both zones. Now, in order for it to register its own host record in DNS using its primary DNS suffix of nuggetlab.com, we have to have this checkbox, register this connection's address in DNS. If we also wanted to register this connection-specific DNS suffix of cbtnuggets.com, then we would also have to manually check this box, use this connection's DNS suffix in DNS registration. Then it would be registered under both automatically. And in fact, I've already registered that automatically. So let me go to DNS over on my DNS server. And we see that in DNS for cbtnuggets.com, where we have a zone that accepts dynamic updates, dcnugget2 did indeed register its own host record for 10.10.10.22. So now any clients that try to find a computer named dcnugget2 can find it under dcnugget2.cbtnuggets.com. And if I ping it, in fact, ping dcnugget2.cbtnuggets.com, then we'll see that it does get a reply. But likewise, I can also ping to dcnugget2.nuggetlab.com .com. And it also gets a reply. Notice that it's getting the same IP address because I have two separate host records using the same IP address, two separate zones. Now, why would we want to do something like this? This might be useful if, cbtnuggets.com is buying out nuggetlab.com, and we have servers that we need to access that are kind of in an interim position where we need to be able to access them through either name. Something like that might be the case. Now, most everything I've talked about so far is how this specific computer, DC Nugget 2, can be identified within various zones, cbtnuggets.com or its default zone where it's also a domain member in nuggetlab.com. However, it makes sense that if this computer can be identified in this domain or in nuggetlab.com, then it might also need to find computers itself in cbtnuggets.com or in nuggetlab.com. And that's what this all relates to up here. This relates to how we resolve unqualified name. An unqualified name is a NetBIOS style name where it's just a flat name. Nugget1 or Mail1 or something like that. It's not .nuggetlab.com and all of that. So anytime it tries to find an unqualified name where the domain itself is not specified, then what it does is it first will look for the primary DNS suffix. So if I just try to ping mail1, then it'll try to actually ping mail1.nuggetlab.com. Can't find it there, then it can also use the connection-specific DNS suffix. It says, couldn't find it there. Maybe we'll try pinging to mail1.cbtnuggets.com. Then it can also append parent suffixes of the primary DNS suffix. So remember I had entered in az.west.nuggetlab.com. We didn't keep it, but we had typed it in there so you could see it in the primary DNS suffix. Well, if we'd entered that in there and decided to keep it, then next time I looked for mail1, then it would do this resolution method. It would say, first I'll try to find mail1.az.west.nuggetlab.com. Can't find it there. Okay. Then we'll try this zone, mail1.west.nuggetlab.com. Can't find it there. Okay. Then finally, it'll go down to mail1.nuggetlab.com as its final attempt at resolution. Now, of course, it makes sense to look for other hosts in one of the zones where we already have a DNS suffix, cbtnuggets.com or nuggetlab.com. But if you have to explicitly be very manual in the zones that you search for, you could append these DNS suffixes in order, and then you could just add in domains, computer training pearls, of wisdom.com or something like that. And then that would bypass searching for names in cbtnuggets.com or nuggetlab.com and instead go explicitly only to the zones that you specify here. Now on the Wins tab, this has to do with something that Microsoft doesn't seem to care much about anymore, and hopefully we're able to get away from as much as possible. Wins resolves flatnet BIOS names to IP addresses. You see, DNS does resolution like this, dcnugget2.nuggetlab.com, dcnugget2.cbtnuggets, and so on and so forth that we've looked at earlier. Well, Wins only resolve dcnugget2 to an IP address. That's it. This is really a throwback from older networking methods that Microsoft has used in the past, and it's got a lot of limitations in terms of the kind of namespace that you can use, because after all, it's just a flat name. It's also got a lot of limitations in terms of the fact that it will also increase network traffic. It's more stuff to administer. So Microsoft has kind of shied away from using Wins anymore, and typically we only use Wins if we have applications that require Wins, and there are applications that will have to use Wins. For example, previous versions of Systems Management Server, or SMS, would depend upon Wins. You might have some kind of an application that distributes security updates to all of your clients or something using flat names. So it would need to also possibly depend upon Wins. But otherwise, we're going to try to use only applications and methods that use DNS because we already have it. We're going to keep it forever probably. So we just want to discard Wins whenever possible and get rid of additional administration and network traffic. Now, if you do have Wins servers, you're still going to have to enter them in here. And I would just click on Add, and maybe I get a Wins server at 10.10.10.50 or something like that. Click Add there. Now I've got a Wins server. If I've got multiple, I'll just add more in here. And again, I can rearrange them with little arrows over here. Now, if you do have Wins servers, then what normally happens with Microsoft networking is your host will automatically register their address in Wins, and you don't have to do anything as administrators with that other than managing those Wins databases and smartly planning out where you want to put your Wins servers. But what predates Wins, where we have the automation there, is something called an LM host file, and this would be a static file that appears on the hard drive, and let me show you exactly where it appears. In fact, it appears under Windows, System32, Drivers, and etc. Now, we don't really have to be too concerned about an LM host file. Here's just a sample of it, and that's why it's .sam. If you have a real one, you won't have the extension on there. Let me just crack this open in Notepad real quick. and you'll get an idea for what kind of stuff is in there. First of all of this is just starts off with a pound at the beginning. That means it's remarked out, if you will, and then it gives you some samples of how it looks. You would enter in an IP address of a server followed by the flat name of that server. And that's pretty much just how an LM host file would work. Now down here we have some NetBIOS settings here as well. By default, it will allow NetBIOS settings because DHCP by default allows it, but you can configure DHCP, and again we'll talk more about DHCP later. You can configure DHCP to not allow NetBIOS resolution over the network. And why would you want to do that, however? Well, you see, NetBIOS works over port 137, and there are certain vulnerabilities in terms of security using NetBIOS. And there are hackers' tools, for example, that can exploit that port and then can look for SMBs or server message blocks or SMB shares, look for any shared folders, and then it can open up those shares even if they don't actually have permission to use them. Now, that's more pronounced on legacy operating systems like Windows 95 and 98. On NT-based operating systems such as Windows Server 2003, it's not as pronounced and it's a little bit more difficult to exploit, but certainly some possibilities still exist there. So you could explicitly also enable NetBIOS or disable it if you had some security concerns with NetBIOS. And as an example of these NetBIOS vulnerabilities, let me just take a brief tangent here for something kind of fun. Not too long ago, my ISP made a changeover, a major networking changeover, and someone forgot to close down port 137 on their routers. As a result, I was able to use a hacker's tool, and which is a very easy tool to use. Any grade schooler could use it. And I was able to browse through all of the other users on my own ISP, and I could see any shares that they had. Some people had shared out their entire hard drives. And I could look at whatever I wanted as if it were my own. In fact, one guy had a QuickBooks file, and since I use QuickBooks for my own business, I was able to open it up and look, there it is. And of course, I blacked out anything that could be, incriminating or anything like that. But look, I found out this guy's bank balance. I mean, for crying out loud, this is very sensitive information. So, on most of your NT-based operating systems, especially that are closed or that are already behind firewalls, which should always block out port 137, you might not have to disable NetBIOS over TCP/IP. But if you're even at your home network, if you're bare and wide open on the internet or something like that, then certainly you want to disable NetBIOS over TCP/IP, and you should also invest in an inexpensive firewall. Now, as far as the corporation is concerned, if you have any legacy-based operating systems such as Windows 95 and 98 within your network, then a dishonest administrator or a dishonest person within your network can scan all the NetBIOS ports within your own network because they're not being blocked by the firewall. So you are still vulnerable there, and if anyone is savvy, then they could possibly exploit that capability within NetBIOS. Now, under the options item here, we have TCP/IP filtering, and this will allow you to control what kind of traffic will reach this computer. And you click on the properties here, and then you would enable TCP/IP filtering. Now, mostly we're going to have, in most corporations, a firewall solution or some other security solution that will take care of this for us. But as a rudimentary method for restricting traffic, you could enable TCP/IP filtering. And then by default, it allows all traffic over TCP/UDP and all IP protocols. But if it were, let's say, a web server, then I could permit only, and then click Add, and permit only port 80 if that's what we're using for all of our web traffic, which is the default. And then that would allow only that. And you can do a similar function for UDP and IP as you see over here as well. In this nugget, we opened the junk drawer of TCP/IP configuration, where there are a lot of various radio buttons and checkboxes and all that kind of stuff. And in these TCP/IP properties, one of the first things we look at is the default gateway to make sure that we can route properly to other networks, including the internet, or so that you can avoid routing to other networks, including the internet, if you want. Then we took a look at important DNS suffix settings, because you want to be able to know how this specific computer is identified in its zones and how it searches for other systems. Well, the DNS suffix settings are really important for that. We took a look also at dynamic DNS, which is how your system will register its own host record on a DNS server in its zone. We took a look at NetBIOS settings. We saw that, boy, there could be some security vulnerabilities there. Fortunately, in current versions of Windows that are based on NT, they're not as prevalent as they used to be, but nevertheless, you might want to be careful about that and lock down NetBIOS wherever possible, as long as you don't have any applications that depend upon NetBIOS. And then we also took a look at TCP/IP filtering if you want to be very granular and specific about what kind of traffic can go to and from your server. I hope this has been informative for you, and I'd like to thank you for viewing.